Hello, here is the proof of the quadratic formula that I had promised. Let's get after it. The goal is to show that if I want to solve for x in the generic standard form of ax squared plus bx plus c equals 0, that is equivalent to writing the equation as x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. If I can rewrite this solving for x, I've got a quick way to solve every time. A lot of people use it and never understand where it comes from. So let's take a look. As I write down my standard form, I want to take a moment to acknowledge that we will be using the technique of completing the square, which we just studied in class, so this lends itself appropriate to the situation. To do so, let's begin by taking away this old c term, just like we do when completing the square. That leaves me with ax squared plus bx equals negative c. Now, I also want a leading coefficient, the coefficient of the x squared term, to be 1. So I'm going to divide both sides of the equation by a. That now leaves me with x squared plus b over a times x equals the opposite of c over a. Now my next step will be to take half of this b over a term and square it and add that onto each side of the equation, which leaves me with x squared plus b over a times x plus b over 2a quantity squared equals negative c over a plus b over 2a quantity squared. Okay, I now on the left-hand side have a perfect square. It is x plus b over 2a quantity squared. On the right-hand side, I'm going to write this as negative c over a plus b squared over 4a squared. Okay, I'm going to start a clean page here. I'm going to copy this over. And here we go. Continuing on, my next step would be to take the square root of both sides, which on the left-hand side would leave me with x plus b over 2a. And on the right-hand side would leave me with positive or negative square root of negative c over a plus b squared over 4a. Now, in order to combine the terms under the radical here, I have to have, oops, sorry, that's an a squared. I have to have common denominators in order to combine these terms. So my common denominator is going to be 4a squared, which means this first term I have to multiply the numerator and denominator by 4a. Doing so, my next line reads this. Positive or negative square root of 4ac, and that's a negative, plus my b squared from the other term, all over 4a squared. Okay, cool. Starting to look familiar. Now I'm going to take the square root of the numerator and denominator independently on the right-hand side. So that leaves me with positive or negative square root of, I'm going to flip-flop these two, b squared plus a negative 4ac all over. The square root of the denominator becomes 2a. Oh my goodness, is this starting to look familiar, hey? All right, almost at the end. I've got to clean away this b over 2a from the left-hand side from the x so that I have the x by itself. So let's do that. I will subtract b over 2a from both sides. All right, leaving me with x equals negative b over 2a plus or minus the square root of b squared, and I'm going to go ahead and rewrite this part as minus 4ac all over 2a. And we're almost there. One more line. I've got common denominators, so I'm going to write the right-hand side as a single rational expression. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Ta-da! It's done! That is the quadratic formula. I have solved the standard form for x and have generated the quadratic formula. We'll flip back here and we see here was the standard form. Here's the quadratic formula. It's just solving this for x by completing the square and some other clever moves, and we get down to this. Hope you enjoyed it as much as I did. Have a good day.